Hey there, and welcome. Today, we're going to talk about one of the most fundamental, rock solid rules of the entire universe. Seriously, it's a law that dictates how everything works, from a simple falling apple all the way to the stars themselves. We are talking about the law of conservation of energy.
So let's just start with the biggest question right out of the gate. Can you actually create energy out of absolutely nothing? Or, on the flip side, can it just, disappear? Poof, gone. I mean, it really feels like we use up energy all the time, right? But what is really going on? Well, let's find out.
And to get to the bottom of this cosmic mystery, we don't need a fancy multi-million-dollar lab. Nope. All we need is something you see every single day, an object falling.
Okay, so picture this with me. You're holding an object. Let's just say it's a ball. It has a certain mass, which we'll call m, and you're holding it up at a specific height above the ground, which we'll call h. Pretty simple setup, right?
So right before you let it go, that ball is just hanging out, perfectly still. Its velocity is zero. But here's the thing. Just because it isn't moving, that does not mean it has zero energy. Oh no, it is packed with this kind of stored up energy, just waiting for its moment.
And now for the fun part. The second we let go of that ball, everything changes. That stored energy immediately starts to transform into something completely different. So let's break down the two types of energy that are at play here. So on one side, you've got what's called potential energy. The best way to think about this is potential to do something. It's all about the energy stored because of where the object is. In this case, its height. The higher up it is, the more potential energy it's got. Then on the other side, we have kinetic energy. This is the energy of motion. And as you can see, the formula for it has to do with its mass and its velocity. So when that ball is just sitting still in your hand, its velocity is zero, which means its kinetic energy is also zero. Makes sense?
Okay, so you let go. As the ball starts to fall, what happens? Well, its height gets lower and lower, so its potential energy goes down. But at the very same time, it's picking up speed, right? It's accelerating, so its velocity is increasing, which means its kinetic energy is going up. You see what's happening? It's a direct trade-off. One type of energy is literally turning into the other. So potential energy is becoming kinetic energy. But here is the most important part of this whole thing, the key to the entire puzzle. While these two energies are busy changing, one going down and the other going up, something else, something crucial, is staying perfectly, absolutely constant. And that right there is the big idea, the law of conservation of energy. It's a simple but profound rule that says you can't just make energy out of thin air, and you can't just delete it from the universe. All you can do is change its form. The total amount of energy you start with is the exact same amount you end up with every single time.
Okay, that's the concept, which is cool enough. But let's see how the numbers actually prove it. The math behind this is surprisingly clean, and it shows what's happening just beautifully. Take a look at this table. It lays it all out. At the very top, before the fall, it's all potential energy. Kinetic energy is zero. Then, right before it hits the ground, it's pretty much the opposite. All kinetic energy and no potential. And here's the kicker. Look at every single point in between. As one number goes down, the other goes up by the exact same amount, which means that last column, the total energy, it never, ever changes. It stays constant. And this constant sum, this unchanging total, actually has a name. It's called the object's total mechanical energy. It's just the energy of its position plus the energy of its motion all rolled into one. And there it is, the whole law in a neat little package. Potential energy, that's mgh, plus kinetic energy, that's 1/2 mv squared, always, always equals a constant number. It doesn't matter how the height or the velocity are changing during that fall. When you plug the numbers in at any given moment, the result is always going to be the same. That's the law, written in the language of math. Now, what's so incredible about this is that it isn't just some neat trick for falling balls. Not at all. This is a universal law. It applies to everything, everywhere, in all situations. It's one of the bedrock principles of physics. I mean, think about it. Energy is constantly changing its costume all around us. The chemical energy inside a battery becomes the electrical energy that powers your phone, which then becomes light from the screen and sound from the speakers. The sun's energy travels millions of miles to get converted into electrical energy by a solar panel. In every single one of these transformations, no energy is ever lost. It just changes its job.
Now, you might be thinking, hang on, what about things like air resistance or friction? And you're right, in our simple little thought experiment, we kind of ignored those. But even in the real world, the law holds true that energy doesn't just vanish, it just gets converted into other forms, like a tiny bit of heat caused by the ball rubbing against air molecules. The total is always, always accounted for. And this is the very reason you can't build a perpetual motion machine. Some energy will always be transformed into heat through friction, and unless you keep adding more energy in, the machine will eventually stop. The energy isn't lost, it's just less useful for making the machine go. Which, brings us to one last thought to leave you with. If energy can't be created or destroyed, if it's always conserved, what does it mean when we say we feel like we've run out of energy? It's not really gone. So where did it go? Something to think about.